Hello friends, welcome back to the latest video of StatPro for fresh civil engineers. In the last video we have discussed the analysis and design of G+3 RCC building by using the StatPro design command. Okay, now in today's video we are going to again design a G+3 RCC building, but by using the another way, or by using the manually putting all the giving the all the input to the software. Okay, so let's begin with that. First, let's create one simple plan for the purpose of analysis. So I'm creating a plan. Adding a beams and nodes. So this type of simple plan I have created for the purpose of understanding. Next, now let's start with the modeling of the G+3 building. So here you have to go for addition of the foundation deck. So select the node cursor, select all the node points, go in the translational repeat command in y direction. Let's keep the depth of foundation as 2 meter. Okay, then select the front view, selecting all the beams over here. Again go in the translational repeat by keeping the floor to floor height as a 4 meter. Give the 3 steps, link steps. Okay, so this is ground plus 1 2 3 floor model is get created. Now next we have to define the properties. So first go in the front view, let's create the plate over here. You can say check over here, all the plates are get selected and select on this. So 12 plates are get created over here. Okay, now let's define the properties. So first define the section, rectangular section. I am again defining two rectangular section size, 0.35 to 0.23 for the beams in x and z direction, and then 0.4 by 0.3 for the columns in y direction. So here, and one more, thickness 0.2 for the slab. Close. Now let's assign all these cross sections. So selecting first, select the beams parallel to x and the beams parallel to z direction. Assign to selected beams, assign, yes. Then next select the beams parallel to y direction. Assign to selected beams, assign, yes. Then next select the plate thickness, select the plate parallel to xz direction. Assign to selected plate, assign, yes. Okay, now in this 3D rendering view you can check the whether all the elements section properties are assigned or not. Okay, now next go in the support, create the fixed support, add over here. Go in the front view, select all the bottom nodes, then check over here. Assign to selected node, assigns, yes. Just check it out. Just select this property section. Go in the general, add the support, create over here, add support 2. Can check over here the select all the node points, then assign, yes. Okay, next go in the load and definitions, add the load, dead load, add, then add the next live load, add. I will add one more combination of 1.5 dead load plus live load, give the factor 0.5, close. Okay, now in dead load let's add first the self weight. Okay, then next wall load as a member, minus 5 kilonewton per meter for external walls, then minus 3 kilonewton per meter for the internal walls. Okay, next one more, add the floor load as minus 3 kilonewton per meter square, minimum range is 0, maximum let's give it as a 15, close. Okay, now let's assign the self weight to all the members, assigned to view, yes. Next, for this uniformly distributed load, select the top view, all the external beams, select to assign beams, assign, yes. Then select the internal beams, assign, yes. You can check over here. Then go for live load, add over here a member load of let's say minus 2.5 kilonewton per meter, add, close. So assign this to all the beams parallel to X and parallel to Z direction. Okay, so now the loads are properties get assigned, support is assigned, load and definition is also assigned. Next is analysis and print, all, add, close. Perform analysis, assign. Okay, then run analysis. Two errors, let's check what is the error. Elastic modulus, the members is not get defined. So here 11, 12, 13, 14, all the members elastic modulus is not defined. Let's check over here. So this is the six, go in this general, 1 to 10, 20, then column, for the column, okay, or we can go in this material property, select the concrete, assign to view, assign, select the concrete, assign to view, assign, yes. Okay, so all the materials are of concrete. Now again let's go for the analysis, perform analysis, assign, run the analysis. Okay, 0 errors, 4 errors, done. Now as analysis is completed, we can easily go for the design. Okay, now in the last video we have discussed this method where you can go carry out the design by using this option of design. In that you can go in the concrete and then adding and defining the parameters, you can complete the design part. Now here there is one more option to design the members as concrete design. You have to click on this option as concrete design. Okay, so this will opens a new window over here. In that you have to select, first thing is the envelope. In envelope you have to create the two envelopes, first envelope of beam and second envelope of column. So here I am creating first of all the envelope of beam. So here all the beams are get selected. Here you have to click on new envelope, let's say as a beam. Okay, so we assign for the combinations for all the different type of loadings. Okay, Again I'm selecting here the front view, creating the second envelope of column. Whatever the first envelope created, that will be appeared over here. Okay, now the next second for the column. Okay, so again all the loads. Okay, so that second envelope is appeared over here. Okay, after the envelope is get completed, next thing you have to go in this members. Again select the front view, selecting all the beams in X and Z direction over here, and here you have to go in the members and form the auto members. Okay, then select the vertical. Here you have to make the selection by pressing the control. Can go in the members, auto form the members. Okay, now you can check over here all the members are get numbered. Alright, the next job you have to go in this design layer. Okay, next is group and brief. So in group and brief, again you have to select the front view, select all the beams in X and Z direction. You can check over here all the X and Z direction beams are get selected. Select over here new brief. So in that one you have to select the code as IS 456. Design type is beam design. Let's say here group of beam. Okay, now when you click OK, then here the different parameters related to beam design, that window is get displayed. Here you can see in the first general information, in the second tab main reinforcement and shear reinforcement. So first go in the general. Normally in the case of beam you are providing a cover of 40 mm. So here we are changing that cover to 40 mm. Then next, if you want to change the grade of concrete, the by default here it is considered as M20. You can change it over here as M25. Then you can go in the main reinforcement. Here top bar reinforcement criteria is given. So minimum I keep it here 10 and maximum as a 12 size. Then here minimum size I am keeping 12, maximum as 32. Okay, the grade of steel as Fe500. Then similarly for shear reinforcement I am changing the grade of steel as Fe415. Okay, next we have to go in this first column group, select all the vertical beams. Here you have to press this control button. Okay, for selection of all the vertical. Then go in this new brief. Again IS 456, select over here column, give the name as column, click OK. Now you can see here the parameters related to column, that will be open over here. Now again change the grade of concrete as M25. Then here main bar as a Fe500, ring spacing as Fe415, minimum maximum size of diameters is provided over here. Right, then column factors, member load case. So here I have to add all the cases. Okay, so that will be created over here. Now next again you have to select the members in horizontal or X and Z. You can check over here, and here you have to click on this new design group. So design group number 1 is of beam. Okay, now I am creating the second design group of column. You can click over here group of column. Okay, so here you can see design group 1 and design group 2. These two groups are get created, and in design group 1 there are members of X and Z, and in design group number 2 there are members along Y directions are there. Right, so now here I am selecting the design group 1, and I have to go in this design layer, concrete member, go in design, select all the members, click on design. Okay, so here you can get okay, means all the design is get carried out. Okay, now let's check the layout. So when you are clicking on this main layout, you can see over here the bending moment diagram, right? And then here in this figure you can see the different bars provided, the top bar and the bottom bar. Okay, then this is the cross sectional view, 2 top bar, 2 bottom bar. Here the details related to 2 top bars of 10 mm diameter and bottom bars of 12 mm diameter is provided, right? Whichever the beam you are selecting, the data related to that beam is get displayed over here. Even you can change this section location, and wherever you want you can find out how much is the steel provided over here, right? Again you can check over here the shear enforcement also. You can check that shear force and bending moment diagram in y direction, in z direction, in this view also. Again you can check over here the main reinforcement details. Like here, if I am selecting a beam, then in that beam for a different span or distance 0.2, 0.25, the total length of the beam is 3 meter, and at different location how much is the movement developed and how much is the 2 bars of 12 mm diameter, T and B, that will be for top and bottom bars. Okay, so that will be displayed over here. 2 tension bars will be there. Here the bottom layers, and here will be the details of top layer is provided. So in this way all the details related to design part that will be get displayed or can be done by using this option also. You can go over here. Okay, you can check any member, a vertical member. For that you have to go in the design group number 2. So all the vertical members column related details will be here. You can check here the main layout of the column, cross section size, then thickness, then the design of all the columns when we perform. Okay, so here if any column get failed somewhere, then here shear, this column is get failed shear, that details will be displayed. So here I am checking now main layout, this column. So here the bending moment diagram, then the 4 number of bars that will be located in this way. Results related to column, all the values and positions of the bars that will be displayed in main layout, then in shear layout, right? If I am selecting this, any column you can take over here, the external column, the column at which more load is there. So likewise everything, all the details that will be get displayed here in these windows. Export drawing and all that is also available over here. Okay, and you can generate these results and all that, main reinforcement, shear reinforcement, you can check over here in different views also. So in this way, by using this concrete design or by using this design command, by both the way you can carry out the analysis and design of G+3 RCC building. Hope all these lecture series that will be beneficial for you to at least came to know about the basic commands which are used in the StatPro, and all of you are get trained in the basic part for the StatPro. We have come up with one more additional lecture for you guys, that in which there are some shortcut commands are get introduced, or introductory part of those commands will be introduced in those lectures. So I hope you like all these lectures. Thank you.